I want to integrate this. And I can't just straight up integrate this very easily. I'm probably going to have to use U substitution. If this was flip-flopped, if it was a reciprocal of this, you could just divide both sides by this. But since you have two pieces on the bottom, you can't do that. You can't do long division, really. It's kind of weird, but you couldn't really do long division. So let's do a U substitution. Let's use the bottom, because this is probably going to be an ln involved. So if we set the bottom equal to u, that would be x to the 1/3 minus 1. You want to always change that. I think you know that by now. You now want to derive this, and you want to put the dx over, because that's the whole premises. So that'd be 1/3 x to the negative 2/3 dx. From there, you look at this and go, this has nothing to do with this. That doesn't help me. Okay, so you're kind of like, what do I do with that? How do I go from there? You get a little kind of, Now, what we're going to do here is, if I go back to this equation right here, the red one, and what I'm going to do is I'm actually going to square. I'm going to get the u to the third by itself. Sorry, the x to the 1/3 by itself. So I'm going to take this one. Actually, before I do that, let's rewrite this one. Let's rewrite this one. What you have here is you have, if you have du equals 1/3 x to the 2/3 dx. I'm going to rewrite this one more time as, I'm going to move this over. If we multiply both sides by 3 x to the 2/3, that will cancel. So do you have 3x to the 2/3 du equals dx? So what this ends up looking like, it's kind of creepy, but you now have x to the 1/3 right here. Okay? And you have a u on the bottom, you have a du, and you have this 3x to the 2/3. So if we go back up here, I replace dx with these two pieces, correct? Dx gets replaced with this right here. This is still x to the 1/3. U is now on the bottom. But I got to get rid of my x's. So if I kind of group this up, if I group this up, won't that leave me just an x on top? But looking up here, could I solve this for x? It won't be very pretty. So I really kind of can't solve this for x. So, but are we okay? Hopefully right here again, we replaced this, replace this, because that equals dx. This is just the other pieces. So first take, a lot of you go, oh, I'm going to multiply this side of this to get 3x on top. But then you go up here, it doesn't really work. And here's the weird thing. I'm going to take this and bring it down here. And I'm going to take this and make it x to the 1/3 equals u plus 1. Is that okay? I added the 1 over to the u. Now, could I go and replace this right here? As well as, could I square this? If I square this, don't you get 2/3? If you square this, you'll get this. You square both sides. If I were to square both sides, I'd come down to here. The reason for that, doesn't this now match the second part right here? So can I replace both of those? All right. Now, you really, if you were to try to make this one and you were to try to cube both sides, then you have u plus 1 cubed, replacing u, which you could also mess with that. Anyways, let's go from here. So when we do all this, we now have the integral. This right here got replaced with u plus 1. This is u. I'm going to bring this on the other side. I'm going to bring the 3 out front. Is that okay? Bring this 3 out front. X to the 2/3 is right here, which would be u plus 1 squared du. Are we okay with that? Now, what do you have on top? You have u plus 1 cubed. Looking at this now, couldn't I have just basically cubed both sides right here and got x equals u plus 1 cubed and replaced, when you multiply these together, x with u plus 1 cubed? I could have done that as well. That would have been just as easy. But I took it as 2 parts. I'm now looking at it, I probably would have done the cubed method. But hindsight, can't deal with that. Now, do you see how here, could I multiply this whole top all together and then divide each term by u, and we have something we can integrate? This is what you're trying to get at. It's kind of weird, very anomaly-ish kind of problem. Now, doing all this, foiling, let me just give you the answer. The answer when you foil this whole top looks like this. You have the 3 out front, you have the u on bottom, and you're going to have u to the 3rd plus 3u squared plus 3u plus 1. Are you guys okay? This, when you multiply this times the square of this, you get this. I'm just saving time. So, from here, you now want to divide each piece by u. So you have 3 and the integral of u squared plus 3u plus 3 plus 1 over u du. Any questions so far? Now, from here, I integrate. This is a very simple integration. It's going to look kind of nasty. But you have your 3 out front. U squared is going to be u cubed over 3. This one's going to be 3u squared over 2. This one's going to be 3u. And this one's going to be ln absolute value u plus c. Now, from there, can I simply plug in u? I'm kind of running out of space, but do you understand? Plug in u and we're basically done. Is everybody hopefully okay with that? When I plug in u, we'll basically be done, but I'm running out of room. So the last thing would be plug in x to the 1/3 minus 1, and we're done. We're not going to finish it due to space.